This is part of a project called CITE, which is Careers in Initial Teacher Education. It's developed slightly because although we have some trainee teachers who've joined us today, this is now much more open and open to a lot of, for any teachers who like to join us. And we've had kind of 3 CPD sessions, this being the 3rd of them, and associated gap tasks, so things to be doing in the meantime. Some of those have been possible, some of those, due to the current situation, have been entirely impossible for you to do. And we understand that completely, but hopefully at some point in the not too distant future, you'll have opportunity to try some of these things out with actual children in your school. The first session was Careers Education and Conscious Bias. We followed that up with one about career aspirations, which was a few weeks ago now. And today we're looking closely at employability characteristics and role models. I'm just going to review last time's session just quickly, so you've got an idea of where we're up to, because some of the things that we talked about will be relevant in today's session. If you haven't been to any of these sessions before, do not worry, it stands alone as well, so you'll be able to get something from it. So we looked last time at gendered career choices, and particularly we were thinking about what young children wanted to be when they're older, and how that changes over time, or how that hasn't changed over time. And over here we've got 2 slides, 2 graphs here. On the left we've got girls' aspirations. So we asked girls age 8 to 11 in 4 of our schools what they wanted to be when they grew up, and they were able to give us 3 answers. And this gives you a breakdown of what they all wanted to be. So teacher being a very popular answer, and teacher's always been a very popular answer throughout career surveys for a long time now. For boys, there's a massive spike here for footballer, which I think you'll all recognize from your teaching as well. There's some interesting ones here that are much more, I suppose, current, or they turn up in more recent surveys. Things like YouTuber and streamer are really high for the boys here at 13% of the careers, total careers used fit in that. But what you can also see is there's a really clear you can really clearly, if I hadn't put girls and boys at the top, you'd be able to guess really quickly which were the girls and boys by drawing on common stereotypes. So careers aspirations are still heavily stereotyped, and in our first CPD session we were talking about where that kind of stereotype came from, and some of that is to do with society, some of that is to do with family, and some of that is to do with schooling as well. Okay. So we talked a little bit about the benefits of contextualization in order to help children understand that STEM careers are far more broad than just people in lab coats blowing stuff up. And they're not just that one word scientist, that there are multiple different science careers. And you'll all know the benefits of contextualization there. And we'd created a tool, the primary careers tool, looks a bit like this, in order to regularly, I suppose, introduce children to scientists and different scientific careers. So maybe if you were studying rocks in year 3, you'd be doing, you might show them who a geologist is. And a slide like this has a general title, which is expanding their vocabulary in terms of careers. A counter-stereotypical image, so putting somebody up as a role model, being that kind of scientist who doesn't fit the stereotype of that scientist. So for a lot of that you might expect kind of the stereotype to be a male scientist, but there are some of our STEM careers where the counter-stereotype is male. So for example, nurse, which is what part of our STEM careers database, you want to think about breaking the other stereotype there. We've got an age-appropriate careers description, and all this was available on our website. And if you've not seen this before, I'll make sure that link is sent out to you so you can have a detailed look. This is aimed at year 6s, but of course you take the information on our website and you break it down in order to use it appropriately for the year group. Some attributes, and that's what we're going to focus on a lot today, and a question, a nice open question about what could you be? Could you be a geologist? Not do you want to, because we found that was quite, you had to give a very much a definite answer about what you wanted to be when you're older. And I think when children are talking to teachers or anybody in kind of a position of power, as it were, you want to say the right answer. If you want to be a footballer, you're going to say footballer because this person's going to support you to be a footballer. You don't want to say, oh, I could be lots of different things. So we want to explore those possibilities rather than getting children quite narrowly pigeonholed into careers early on. So today, employability characteristics. We're going to find different ways to describe people who work in STEM. So the first activity I'd like you to do, and this is a breakout one, I want you to think of 6 words you'd use to describe a scientist. And can you go with the first 6 that turn up in your head, please? Write them down somewhere, and I'll give you a minute or two to do that. And then we're going to move you into breakout groups to just share your answers with each other and discuss the 6 you've written down. Particularly, I'm interested in if you see any patterns that come up in those 6. So I'll just give you 1 minute now to write those 6 words down. Great. Now, Carol's going to drop you into breakout groups of some people in each group. If in those groups you could discuss the 6 words you've written down, and be someone from each group, can you please be prepared to kind of feedback anything you've found so we can look for patterns across the whole group. And this breakout will be 5 minutes long. Just with those breakouts, if you're not comfortable or not happy in those breakouts for any reason, you can leave those breakouts and come back in this space at any point you want. I think there's a leave button on the screen, or you can speak in the chat to myself or Carol if you want to raise any concerns. Brilliant. Thank you, Carol. If you could put people into the groups now, please. Yeah, so those 6 words to describe a scientist. I'm going to talk a little bit about how we've been working with some groups of children to explore that same idea and take it onto an activity that we've come up with, we've created, that we've tested in a number of schools now that kind of address some of these stereotypes or this lack of understanding about what that job scientist is and what they actually do or the skills they need. If you go to Google and you search for scientist, you get quite a diverse picture in terms of men and women doing science, which is nice. And I think that's a significant change over the past, 5 or so years to be able to see this. And you do start to see some other stereotypes pulling through though. So all of these scientists are wearing lab coats. So there's a significant stereotype there, which I think is quite close to that idea of that fellow with the crazy hair and the explosion. That man's always wearing a lab coat. What's really interesting about this screen grab is that I did it this morning, is that actually a lot of the images that have women on there are from news articles that are about the fact that there are women in science. And I do wonder what would happen if you removed that part of the search. Lab coats, explosions, colourful chemicals, gloves, microscopes, but there are a heavy set of stereotypes in those. So what do children say when we write or ask them to describe a scientist? There's 2 ways that we can do this. There's a really common way that's been around for quite a long time now called the Draw a Scientist test, which is the one you can see on the screen there. And you might have seen it, or you might have even done it with the children. This has been around since the mid-60s. Children and adults are asked to simply just draw a scientist. It's an easy test to administer. It's a good advantage there. But there are a number of methodological issues that have been raised. It relies on drawing ability. It relies quite heavily on you being able to understand what someone's drawn. Sometimes it's not clear on gender in the pictures. It causes us to force a single stereotype. But these sort of tests are used quite regularly. We use something similar, but without the drawing. What we wanted to do was to ask children to, before we start an intervention, to write down 6 words that they would use to describe a scientist. And this was from a school in the Northeast, we've got data from years 3, 4, 5, and 6 in this. So there's a lot of words, and we took all those words and we categorized them into various different kind of bins. We had things like stereotypes, we had positive attributes, negative attributes, that kind of thing. And the results come back quite interesting, that nearly half of the words chosen were classed as stereotypes. So stereotypes for us were things like intelligence, but also things like lab coat, chemistry, things exploding, frizzy hair, mad scientist, that kind of thing. Of all the stereotype words, 60% of those were some form of intelligence, and a lot of those were about high level intelligence. So not just the word clever, but brain box, genius, that kind of thing. That word doesn't say statistically. Girls were statistically more likely to use positive sentiments to describe scientists, and that was 24% for girls and 15% for boys. And what was really interesting here is there was very few gendered words used. In fact, across the whole set, man was only mentioned 3 times, and that's out of, what will it be, about 700 words altogether. So we've been using this 6-word test to evaluate the effect of different interventions on children's misconceptions of science. And what I'd like you to do now is just a second breakout to have a look and discuss those findings. So just quickly sum it up again, that we asked them to write down 6 words. We took all those 6 words and categorized them. Half of those words were stereotypical, and of those words, some 60% were in terms of intelligence. So have a look through those and see if there's anything interesting there of those bullet points that you expect or wouldn't expect to see when asking that question. The same question I asked of you, but asking of children. So just a bit of a look at some of the words that they used: mad, brainy, clever, things like test tubes and white coat, nerdy, special glasses, careful, talented, boy or girl. So some people, I think it was 1 or 2 children wrote down that actually it could be anybody. Talented, funny, awesome, so positive sentiments there, hardworking, observant. So let's move on to think about what the actual characteristics that successful scientists have, or what you need if you want to do a STEM career. And we'll call these employability characteristics. And I'll talk a little bit about where the next set come from. So if you have a look down these, you've already discussed some of these words yourselves. You came up with them in your 6 words task earlier on. And these are a set of characteristics that we've pulled together from various different places. They come from the WISE report, so Women in Science and Engineering report. They come from the Royal Academy of Engineers, and we pulled together a series of documents to work out what is it that scientists think scientists need to be good. And there's 16 there, and there's one missing, or there's not one missing, there's one there that we've just been hammering slightly that is totally removed from this set. So you won't spot the word intelligence, because as we've just been talking about there, intelligence is a barrier to studying science for those who don't feel they fit with that. Whereas what we have here is a wide variety of different skills that are arguably just skills for being good at life and good at any job. They're not specifically science related. You can see how they could be transferred across lots of different careers, but also just being a functioning member, a positively functioning member of society. These are useful skills to have. What's really important about these set of skills is they're skills that the children already have. They would be able to describe themselves in these terms already. They might not say they're all 16 of these things, but there might be 3 or 4 of these different skills that they feel match with who they are at the moment. And so if we can link these skills to scientists, we can create that bridge between a child's perception of themselves and their own characteristics, and the fact that some of those already match what geologists do, or what engineers do, or what physiotherapists do. And creating that link, that bridge between the two, may be able to help children see themselves as that in the future. So I'll talk a little bit about the study and the work that we've done in it and the resource. It's called STEM Person of the Week. It was originally called Scientist of the Week, but we broadened it out. And it came together, almost by accident. I was sat down with a science coordinator talking about what they were doing in schools and what we could do with the schools, and they came up with one idea, and I totally misunderstood that idea. And then when we worked together to explain both of those ideas in a bit more detail, we came up with this idea, Scientist of the Week, which is actually really good. And I particularly enjoyed the fact it just came out almost by accident, because we both didn't understand what the other person was talking about. So what we have is a 5-week teacher-led intervention. It's a whole school activity, right from early years up until right from year 1 up until year 6, but can be adapted for early years. And over those 5 weeks, we've got 5 very carefully chosen role models to reflect the diversity and skills needed in the science workforce and the people who work in science. I'll show you some examples in a moment. And each week, as a teacher, as a classroom teacher, you discuss the scientists with their class. You might have the poster up on the wall. There's postcards you can print off so the kids can have the postcards with these skills and attributes on. And rather than praising children in their science or STEM lessons for hard work or the ticks for the things you've done right, which is, I suppose, inherently praising that intelligence, you praise them for showing the skills that were from that previous list that have been chosen for this week. I'll show you some examples in a moment. In fact, actually, it would be possibly helpful for a bit of context. So if I click on that. So that's an example of the set of them. I'll come back to this in a moment. So what we've got here is 5 postcards over 5 weeks with the scientists, what they do, a brief description of their job, but also the skills and attributes that go with them. And over 5 weeks, you meet 5 different people, and we have counter stereotypical role models in there. We have a breadth of different scientists, and they all are attributed with these skills. And these are skills they pick themselves. So we ask them what 6 would you pick for yourself, and then pulled those out. So these are skills they actually think they need to do those jobs. Right, I'll move back and talk a little bit about the research. So before the project, all the children were asked to write down 6 words to describe a scientist. And at the end of the project, we asked them to do the same thing again. We asked them a week later, we asked them a month later, and then we asked them a year later, so a full year after the intervention had ended, to see how those things changed over time. Those words were characterized under those categories here, which we've talked about briefly. This one here, target characteristics, are the 15 words in that first set. See how many of those turn up later on. Stereotypes and intelligence, they were grouped together and then split apart in the analysis. Gender, positive and negative attributes. Positive attributes being skills that are similar to the characteristics, but not quite the same. Sentiments being kind of your warm, fuzzy feelings towards scientists about them being kind and that kind of thing. A set of science words and attributes, so that will be your test tube and your lab coat, and then science careers, anytime that a career turned up, and then just miscellaneous words, either words that I had absolutely no idea what they meant because I couldn't quite figure out how the word orange fitted, or words that we couldn't read. We're going to focus today and look at that stereotypes part of this. There is the rest of the data that goes along this that shows how the different categories changed over time, and we can find a way of sharing that with you separately, but I wanted to focus on stereotypes today. So let's look at those general stereotypes. So here, the blue is before the intervention. So 47% of those words were categorized as stereotypes, and as all stereotypes. And then a month straight after the intervention, we had a massive drop in the amount of stereotypical words that we used, down to 23%. And after a year after the intervention, looking at this purple column here, we're back up to 32% here, but it is statistically significantly lower than it was at the beginning. So we have some confidence to say that the intervention we used contributed to this change here. But of course, we can't wholly say it was entirely us, because there's everything else going around in the classroom that could be supporting that as we go through. Let's have a look when we break this down into looking at general stereotypes next. So these were the general stereotypes. This is your frizzy hair, lab coat, things explode kind of stereotypes. And that's dropped. And what's interesting here is that the drop after one, straight after, continues into a year where it's still lower a year later. So when children are asked again to write down 6 words to describe a scientist, those words are changing over time. However, our final bit is when we look at the intelligence-based stuff, so the intelligence-based words. So you can see here that we've got a large drops by about half straight after the intervention. So the week after they've done this, they're using far less intelligence-based words. But over time, over that next year, we're creeping back up to the point where that 26% isn't statistically significantly different from the 29. So actually, we could argue that it's about the same as it was to start with. And that's particularly interesting, the fact that there are some stereotypes that seem like we can do something in an intervention that makes significant change to them, but some stereotypes that are possibly stronger than others, or are much more resilient to educational interventions. So I'd like you to go into groups and discuss those graphs. I'll put the slide up so you can see. Hopefully you've got this on an email that got sent to you. And so have a discussion about them, and can we have someone different from each group? Can you nominate that person to feedback? So the implications here, which you've just been discussing, are that after the intervention, the children had a broader understanding of the characteristics that scientists have, which is a really, really positive thing. There was a huge increase in the number of those words that we've been using to describe scientists throughout the course of the intervention, turning up in subsequent data collection. Reduced use of general stereotypes, but that point there that clever is really difficult to change. So let's explore the resources. So posters, postcards of a 5-week intervention with a different scientist at the start of each one. You put an A3 poster on the classroom wall, so you've got a talking point all the way through the course of the week. At the start of the week, you would start with 5 or 10 minutes with a slide on the screen that shows that person. And the way that we ran it in schools is we printed them off so they were like postcards, or a bit like bookmarks, I suppose. Postcards or bookmarks where the children got to hold on to the scientist and those skills and attributes all the way through the week, so they could be kind of regularly reminded about what they were trying to show in those science lessons. And this is an example of one of the postcards that we use. So we've got Holly here. She's a marine scientist who works at Northumbria University. And we talked to her about her job, and we asked her what it was about her, what skills she felt she needed to do her job. And she came up with creative, self-motivated, and passionate. And we built those into that paragraph. Really simple paragraph that tells you a little bit about what she does, nothing in depth, and really important, those attributes. And on the back of that postcard, we've got the description of them. Because some of those are fairly difficult words if you've not heard them before, both to pronounce, but also to understand what they mean. So we've got that very primary focused description so that children can understand what those characteristics are. So they have one of these for the week, and the next week they have another one. So the resource is designed there to promote a counter-stereotypical view. So for example, across 5 STEM workers, you'd most likely have 3 female STEM workers versus 2 males. There are 3 new attributes each week. And that praise within those science lessons and maths lessons is focused on them showing those skills rather than them getting the answer right. We want to show children that they already have the skills they need to be scientists. They already share some of those attributes that working scientists say they have already. We also just want to remove that idea of intelligence from this discussion because of the negative, or that how quickly you can remove yourself from that, I suppose, career path because you don't feel like you fit in that box. And that is also interesting. We talked a few weeks ago about the fact that girls are more likely to underplay their own intelligence. So you can see when you balance it with that as well, that intelligence stereotype could play as more of a disadvantage on girls who are underestimating their own intelligence. Well, have a look at the attributes. Again, there's 15/16. So there's 15 from the original sets, and the new sets, we've got an extra one. So that word logical there is built into this next set because it was one that we felt was important, but also one that scientists began saying to us that they would like included as well. Again, really just good skills to encourage children to show, but also good skills to show children they have already. And you can evidence that in the way that we talk to the children. We want to break down those stereotypes and provide that new understanding of the skills needed. So I'm going to show you the 3 sets that exist at the moment, and then that there are plans for kind of more sets. And I imagine by the end of next year, they'll have at least doubled in number. So that you could run one of these every year and have a different set of scientists every year. So the first set, we are collaborating at the moment, and we're funded actually by the Science and Technologies Facilities Council. And they have lots of physicists and engineers, and working with them, we found 5 quite interesting scientists there who were quite keen on being part of the project. And we had conversations with them, and they sent us pictures, talked a little bit about their work and what they did. And we came up with these blurbs about what they do with those in there. The second set is all academics from Northumbria University. And there's another set like this that's kind of in the pipeline at the moment. The same idea again, that we've gone to these academics and talked to them about what they do and give them opportunity to explain it to us. And then we take the time to turn that explanation, which is often quite complicated, into an explanation that works for everybody. And I don't mean works for children, I mean works for most people who are reading about science. This isn't about, it's about making sure the children can understand what these scientists do without having to have studied it up to PhD level. And then we've got a second set of the STFC ones with some quite interesting people there. You've already seen this person over here in the presentation earlier. She's the geologist that features in the previous one. She works quite closely with us, Kate, a polar geologist there. So quite a wide range of different scientists there software engineering. We've also got technicians and apprentices in there as well, because we know there are lots of different routes into STEM, which I suppose might actually, Wendy, address part of a concern there, that there is that A-level degree postgraduate, but there are other routes that get you into STEM fields that are interesting as well, that we might want to talk about. So in our final breakout now, I'd like you to discuss have a talk about that set of resources. They're available freely online to download. You can click links, you can print them off. The kind of base of it is making sure you've got it on a screen and stuck on a wall somewhere. I know that printing one card for every child might be difficult. Also, it'd be worth thinking about this without the cloud of COVID. Like, imagine what you could do with it in a circumstance where you had a lot more children back in the building with you. But also do think about how it could be used should we not get back to normal anytime overly soon. So just in this breakout, and then from this breakout, just come back to any questions about the resource, and then we'll wind it up from there. So your next steps, I think, is to think about, we've had 3 sessions. If you've been to them all, brilliant. You've got lots of food for thought there. And in 2 of those sessions, well, all 3, certainly things you can go and do in school, maybe not right now, but in the future. So after this session, if you could take a little bit of time to think about what you're going to do next based on these, which bits are you going to pull out, which bits do you want to use as is, which bits would you like to talk to me a little bit more about how they might work, that'd be really good for you to do. We'll send you this presentation on, and do get in touch to let us know how it's going. So if you do it in school, we'd be really keen to know with any of the different things. And if you have ideas, we're really keen on ideas. So if you have ideas about how things can work, or if you've got ideas for making them work slightly differently, please share those with us as well. And just thank you for joining us.